In this video, we will be looking at inverse variation. By the end of this lesson, you should be able to analyze a relation to determine whether an inverse variation exists, determine the constant of variation, and represent an inverse variation algebraically. Let's take a look at some definitions. So inverse variation, in our last lesson we looked at direct variation. So this is similar, but it's a little bit different, as you can see with our equation. The relationship of two variables x and y is related through this equation. Y equals k over x when k is not 0. You'll notice that's the same as direct variation. K is not 0. Another difference is the graph of inverse variation. If you remember in direct, it went through the center of my graph. For inverse, it has a different shape. Our inverse variation will generally look like this. It is not going to be a line. It is not a linear graph. And the reason it's not linear, as you can see here, my x is in the bottom. If you remember from direct, x was in the top. X I have in the bottom for inverse variation. Similarly to direct variation, I have a constant of variation, the constant of proportionality. It's the number that relates the two variables. Just like direct, we represent this as k. This is the same as direct. We have that constant k. So let's look at some examples of inverse variation. In this example, we ask, are the equations below inverse variation? If they are, identify the constant of variation or the constant of proportionality. This is k. So if these equations are inverse, we want to identify k. If we look at my first one, y equals 1/2 x, my x is right there in the middle, but this can also be written as y equals x over 2, which is direct. So that is not going to be inverse. If we look at my second example, y minus 5x equals 0, I can add 5x to both sides. Y is equal to 5x. Again, my x is in the top, so this is not inverse. Looking at my next example, y is equal to x over 8. I can rewrite this as y equals 1/8 times x. This is the same as that first example. Again, I have x on top. It is also direct and not inverse. Looking at my next example, y is equal to 8 over x. We notice that x is in the bottom. So yes, this is inverse. And my k is equal to 8. My last example, it's hard to tell in this one because my x and y are on the same side. So just like for this one with the 5x, I'm going to have to solve for y. So I see I have multiplication here between x and y. So I want to do the opposite. I want to divide both sides by x, and I get y is equal to 3 over x. Notice where the x ended. It's in the bottom. So yes, this one is also inverse. And my k here is equal to 3, the number that's in the top when it's over x. Next, we're going to take a look at some tables. So here in example 2, it asks which tables below represent inverse variation. If they do, identify the constant of variation, and we need to write an equation. So we need to identify k and write an equation in y equals k over x. So we have to do two things here. We're going to look at this second example here, this second table first. The other two examples you will talk about in class. So again, just like direct variation, I'm going to use y equals k over x to see if I get the same k for each pair of x and y. So when I write this, I'm going to substitute and write my y value, which is 24, is equal to, I don't know k, over my x value, which is 1. To solve for k here, I need to multiply both sides by 1 so that my 1's cancel. So I get 24 is equal to k. So for my first one here, k is equal to 24. That's for my first one. So let's look at my second one. Same thing, my y, which is 12, is equal to k over my x, which is 2. Multiply both sides by 2. 24 is equal to k. I got 24 again. I look at my next one, I have 3 and 8. So 8 is equal to k over 3. Multiply both sides by 3 so that my 3's cancel. 24 is equal to k. And lastly, I have 4 and 6. So I write 6 is equal to k over 4. Y equals k over x. Multiply both sides by 4 to cancel my 4's. 24 is equal to k. So we notice here when I get the same k for each of the pair of numbers in my table, that is my constant of proportionality. So my k for this one is equal to 24. And when I write my equation, I'm going to write y equals 24 over x. That is my equation, my constant of variation, and my equation, my inverse equation. We can also see our numbers listed as coordinates. So we have which set of ordered pairs represent inverse variation. Again, if they do, identify the constant of variation and write an equation. So just like our tables, we are going to take a look at a set of ordered pairs. If it helps you, you can also write these as a table. You can create your own table. So we can write x and y and fill in the points. So if I look here, -2, 6, I have -2 for x, 6 for y, 3, -4, 3 for x, -4 for y, 5 for x, -3 for y, 12 for x, and 0 for y. We are going to do the same math that we did with the tables before to check to see if this is inverse variation. Again, we want to look at the equation y equals k over x. So I'm going to look at my first one here, 6, -2, so 6 is equal to k over -2. Multiply both sides by -2 to solve for k. My -2's cancel. -12 is equal to k. So for this one here, k is equal to -12. I'm going to look at my second one, 3, -4. Again, I do the y. -4 is equal to k over 3. I multiply both sides by 3 so that my 3's cancel. -12 is equal to k. So I write that. K is equal to -12. For my third point, I have 5, -3. Remember, my y goes first. -3 is equal to k over 5. Multiply both sides of my equation by 5 to cancel my 5's. Here I get 5 times -3, which is 15, which I notice is different than what I've gotten for each of the other ones. Okay. When that happens, when we don't get the same thing each time, this is going to be not inverse. We don't necessarily know if it's direct or not, but we know that it is not an inverse variation. We would need for each of the ordered pairs or each set in the table, all would have to give me -12 when I plugged it into my inverse variation equation. Let's take a look at one more example. In this one, we don't have a table, we don't have ordered pairs, we're given a word problem. So let's read it and see what we need to do. So if y varies inversely with x, so when you see that y varies inversely with x, let's pause and write our equation. Y is equal to k over x. We're varying inversely. And the constant of variation is -6. Let's pause there too. The constant of variation of -6. K is equal to -6. I want to write an equation that represents this relationship. So if I have y equals k over x, k equals -6. So my equation will be y is equal to -6 over x. This is the end of our video. Please make sure you bring your notes to class. We will continue to do examples together.